Hello, dear students. You are warmly welcome to session 1 of Core Mathematics for Senior High School. So, under this session, we'll be delving into the topic sets. Alright, so I believe you are ready. Okay, so let's kickstart. Okay, so before we start off, let's take a look at the session outline and objectives. So what do we seek to achieve by the end of this session? Right, so basically we'll be talking about the general concept of sets, the types of sets, universal sets and subsets, operations of sets, properties of operations on sets, and we'll also be looking at some applications of sets, that is the 2-set problem as well as the 3-set problem. Right, so this is what we expect that by the end of this lesson you should have on your fingertips. Right, okay, so let's begin the journey now. Alright, so what is a set? Okay, what is a set? Okay, briefly, a set is a well-defined collection of items or elements. Right, so whenever we talk of sets, all we are saying is a well-defined collection of items. Right, and when we talk of well-defined, the term well-defined connotes that all the elements within the set have something in common. Right, so when you take the set, each and every member must possess the same characteristic. Right, for instance, assuming we have a set with members such as mango, pear, pineapple and orange. Now, why would we say this set is well defined? Because obviously when you observe the members of the set, you realize that each and every one of them is a fruit. Right, so mango is a fruit, pear is a fruit, pineapple is a fruit, orange is also a fruit. Right, so collectively they are all fruits. Right, and that is what makes them well defined. So when we talk of sets, so far as each and every member of the set has the same characteristic, or all the members possess the same characteristic, the same feature, we say it is well defined, and that is what makes it a set. Alright, so we can have another example like the set of, let's say, secondary schools in Ghana. Right, so we can make mention of popular secondary schools like, let's say, Achimota Senior High, Infante Pim, Accra High, Accra Academy. So when you look at all these schools that I've mentioned, now what is one thing that they have in common? They are all secondary schools in Ghana. Right, so they can form a set. Right, so that is the general overview of set. Right, so let's look at a more mathematical example. So if set P is equal to positive even numbers less than 10, right, so the positive even numbers less than 10 is just the definition of the set. Right, so if I ask you to list the members of set P, you would clearly tell me that set P is equal to 2, 4, 6 and 8. Right, so this is the members of set P. And why do we say it is a set? Because each and every member, or all the members of this set, have something in common. That is, they are all positive even numbers less than 10. Right, so all of them obey the definition of set P. Right, so this is just to give you a general overview of set. Alright, so let's move on. Okay, so let's look at set notation. Right, so how is set denoted? Okay, basically the members in a set are enclosed in 2 curly brackets. Alright, so when we have set A, right, and want to list the members of set A, what we do is that we are going to open two curly brackets, and then we are going to put all the members within the two curly brackets, right? And usually the set is named with a capital letter, right? So we have set A. So as you can see, capital A is equal to, then you open the curly bracket, then you list the members of the set. Afterwards you close the curly bracket, right? So that is a basic notation of set, or that is how set is represented generally. All right, let's look at other notations. So this symbol here, see, that looks like a capital E, right? This symbol here means member of or belongs to, right? So if you see in your book, or if you have an inscription such as 3 and then followed by this symbol A, now how do you interpret this notation? We said this symbol means member of or belongs to. So what this means is that 3 is a member of set A. So this A represents the set, right? So 3 is a member of set A. So that is how we interpret this notation. All right, and whenever you see n into bracket, the name of the set, so you have a small n and then we have a normal bracket, right, containing the name of a set. Now this notation indicates the number of members of that particular set. So n of A means that number of A, or number of members in set A. So here, if we are to count the number of members, you have 1, 2, 3 and 4, right? So number of members in set A is equal to 4. So that is how we denote the number of members in a given set. I believe you are following. Okay, let's now talk about the set builder notation. The set builder notation, this is another way of denoting set, right? So if we want to list the members of a set, we can use what we call the set builder notation, right? And it just gives us the definition of the set, right? It is one of the ways of defining the members of the set. So how do we write it? So we just write the name of the set A is equal to, then we open the curly bracket, then we use any variable. So let's say x. So we are going to have x such that, then we will give a range for the members of the set, right? So here it is x such that x is greater than 0 but less than 5, where x is an integer, right? So this is how the set builder notation is denoted, right? So we have x such that, the such that looks like a colon, right? It's a colon, but then in mathematical sense we don't call it a colon, we call it such that, right? So we have x such that, the x simply represents the members of the set, right? So x such that x is greater than 0 but less than 5, right? And that is just another way of defining set A, right? So here set A is equal to 1, 2, 3, 4. So if I ask you to write this in a set builder notation form, this is how you are going to represent it. A is equal to x such that x is greater than 0 but less than 5, where x is an integer. Alright, so that is all for set builder notation. Alright, let's proceed. Okay, so let's now talk about the types of sets, the various types of sets. Right, so we have a number of them. So let's look at the first one. We have the finite set. Right, the finite set. So what is a finite set? It is simply a set whose last member is known. Right, so it is a set that has a limited number of members. Right, so we know the beginning of the set and we know the end of the set. I believe you get me. So for instance, if I ask you to list the primary colors that we have, right? primary colors include red, yellow, and blue. So it has a distinct number of members, right? So when we talk of a finite set, it is any set that has a distinct number of what? Of members. So we know the beginning, we know the end. So here the set of primary colors is equal to red, yellow, and blue, and it is a finite set because it has a given number of members and it is known as well. So assuming we have our set M to be equal to 1, 3, 5, 7, and 9. Why would we say set M is a finite set? Set M is finite because we know the beginning, that is 1, we know the end, that is 9. Also, it has a distinct number of members, that is 1, 2, 3, 4, 5. So it has only 5 members. So that is what we mean by a finite set. Right. Okay, let's now talk about the second type of set. So that is the infinite set. So this is the opposite of the finite set. Right. So when we talk of an infinite set, it is a set whose last member is unknown. Right. So basically this set has no end. It has no end. It has no limit. So it goes on and on and on and on and on and on. Right. So in fact the word infinite was derived from the word infinity. Right. So when you talk about infinity has to do with endlessness or limitlessness. Right. So it keeps going on and on and on and on and on, just like eternity. And nobody knows the end of eternity. Right. It keeps going on and on and on and on. Right. So it means we can't determine the specific number of elements contained within this particular set. Right. So because we don't know the last member of this set, what we do is that we end the set with what we call ellipses or 3 dots. Alright, so let's take a typical example here. Alright, so set A is equal to 1, 2, 3, 4, 5, 6, 7, and then the ellipsis follows. Now the moment ellipsis ends the set, it tells you that the set is an infinite set because we don't know the last member. It does not have a distinct or a specific number of members. Alright, so that is the infinite set. But then please take note of this. If the 3 dots appear in the middle of the list, the set does not become an infinite set. Right? If the 3 dots, if the ellipsis occurs in between, let's say, 2 members, that set becomes a finite set. It is only an infinite set if the 3 dots ends the list. Right? So let's take an example here. So if we have set N to be equal to A, B, C, D, E, F, and then we have our ellipsis and then Z. Now this set does not become an infinite set. It is a finite set because we know the last member, and that is Z. Right? We know the last member. The ellipsis in between the F and the Z is only telling us that there are more members that maybe perhaps because of time we cannot list. Right? So this 3 dots is just telling us that there are some members between F and Z, but then we can't list them. So that is from G to Y, right? From G to Y. So that is all that this ellipsis is telling us. But then if the ellipsis ends the set, that is where it becomes an infinite set. So please take note of that. Alright, I believe you're okay. Okay, let's proceed. Okay, we also have the now set. The now set. Okay, now set. Now this is also known as the empty set. The empty set. Alright, so as the name suggests, it is a set which has no member. Right, so there is nothing within that particular set. Alright, so assuming I ask you to list the members of set R, and the set R is simply a set of all fishes in the forest, right? So if I ask you, give me some examples of fishes that live in the forest, you will tell me that no fish lives in the forest. So it means that set R will have no member, right? There will be no member in set R. So set R becomes a null set. Alright, it becomes a null set since there is no fish that lives in the forest. Alright, so that is a typical example of a null set. Alright, and a null set are denoted by two empty curly brackets. Right, two empty curly brackets. So there is nothing inside the curly bracket. Right? Or there is another symbol that is used to denote the null set, and that's it. There's it. So it's like a zero with a diagonal line, right, drawn across it. Right, so a zero with a diagonal line drawn across it. Right, so that is how we denote a null set. So it means that here our set R will be equal to the two empty curly brackets or the symbol here. Alright, so we can also have another mathematical example, such as if I ask you to if I say let's say set A is equal to prime numbers that are negative. No, okay, let me put it this way. If I say set A is equal to even numbers that have a remainder of 1, okay, so I say set A is equal to even numbers that have a remainder of 1. Now you know that even numbers do not have any remainder. Even numbers do not have any remainder when divided by 2, right? So if I say that set A is equal to the set of numbers that leave a remainder of 1 when divided by 2, you tell me that it is none, right? It is 0, right? So set A will also be what? Be a null set, right? So that's all for null set. Let's move on to the next type of set. Okay, so we have the unit set. The unit set. Alright, so this is a set with only one member. It is a set with just one member. So if I ask you to list the members of the set such that let's say we have set B, and I say set B is a set of all mammals that fly, right? All mammals that fly. Now the only animal or the only mammal you can make mention of is the bat, right? So the bat becomes the only member in set B. So we say set B is a unit set, right? Because it has only one member, right? So that's what a unit set is. Whenever you hear the word unit has to do with one, just one. So let's look at another mathematical example. So set P is equal to positive prime numbers that are even. Positive prime numbers that are even. So if I ask you to list the members of set P, the only member you can make mention of is 2, because apart from the number 2, no other even number is a prime number. So 2 is the only even number that is prime. Alright, I believe it's well understandable. Okay, let's move on. Alright, so let's look at two important concepts under sets, right? So let's look at universal sets and subsets. So what is universal set? Okay, universal set is basically a mother set, okay, a broader set, a wider set that is made up of smaller sets known as the subset, right? So universal set is simply the wider picture, right, that contains smaller sets known as what? A subset, right? So for sure Africa is a universal set, and then Ghana is a subset. Why do we say that? Because Africa as a continent is made up of a number of countries, right? And Ghana is just one of the countries contained within Africa. So Africa serves as that larger set, that larger group, and then Ghana becomes a smaller set within the bigger set of Africa, right? So basically all continents can be seen as universal sets, and then the countries within those continents can be seen as what? As subsets, right? But then we can also talk of subsets and universal sets to be subdivisions within a wider group, right? So for instance, if we are to take Africa, we can have subdivisions like West Africa, North Africa, Central Africa, South Africa, Eastern Africa, right? So West Africa can also be a subset of Africa, right? So we can talk of subsets to also mean subdivisions within a wider group, right? So West Africa is a subset of Africa, right? And Ghana can also be a subset of West Africa, right? So subsets are in levels, so we have different levels of subsets, right? And we have different levels of universal sets. But then the ultimate thing is that universal set must contain subsets, right? So let's look at this typical example here. So if we have set A to be equal to parrot, sheep, ant, eagle, donkey, and cockroach. Now, first of all, each and every member within the set is a subset of set A, right? So parrot is a subset of set A, sheep is a subset of A, ant is a subset of A, eagle is a subset of A, donkey is a subset of A, cockroach is a subset of A. But then we can also have subdivisions within this wider set based on what the members have in common. So we can look at more close characteristic between the members of the set. So for sure, set A will be the set of all animals, right? So parrot, sheep, ant, eagle, donkey, cockroach, they are all animals in general. But then we can look at specific characteristics, or let me say common characteristics that bind some of the members together. So for sure we can group parrot and eagle in a different set. We can call it set B, right? And then we can group the sheep and the donkey in another set called set M. We can also group the ant and the cockroach in another set called set I, right? So you can see that parrot and eagle, they have something in common. That is, they are all birds. Sheep and donkey have something in common. They are all mammals, or they are both mammals. Ant and cockroach have something in common. That is, they are both insects, right? So it means we can have other sets, right, under the bigger set of set A. So we can say set A is a universal set, and then set B and set M and set I are subsets, right? So that is the general concept of universal set and subset. Universal set being the broader or the larger set, and the subset being what? The smaller set. So subdivisions within the bigger set. I believe it's well understood. Okay, let's move on. Okay, so let's look at how we denote universal set and subset. So this is how we denote universal set. So it looks like a capital U, right? But then there's a small extension here. Okay, there's a small extension here. So that is how we denote universal set. We can also denote it like a G, a capital G, but then like a styled one, okay, a styled E, right? So that is how we denote universal set, and this is how we denote the subset. It looks like a C, right? It looks like a C, right? So let's look at this example here so that we see how we can use the notations of universal set and subsets to represent it. Okay, so if we have a universal set to be equal to 1, 2, 3, 4, 5, ellipsis 10. So once again, this ellipsis here is telling us that there are some members between 5 and 10 that we have not listed. Okay, that is 6, 7, 8, and 9, right? So this is a finite set, right? So just to remind you of the finite set. Okay, we also have set A to be equal to 2, 3, 5, and 7. And then we have set B to be equal to 1, 3, 6, and 9, right? So clearly you would realize that set A and set B are subsets of the universal set U. Alright. The reason is that all the members in set A can be found in set U or in the universal set. Similarly, all the members in set B can also be found in the universal set. Alright, so if you want to say A is a subset of U, this is how we are going to denote it. So A is a subset of U. So this symbol here means subset, right? So A is a subset of a universal set. Now we can rewrite it in a different way. Okay, so you bring a universal set first, then you would invert the symbol. So you flip the symbol. You get me? Such that the pointing end faces the A, right? So here, you see here, you can realize that the pointing end is facing the A, while the open end is facing the universal set. Right, so we can also turn it the other way around. So we bring the universal set first, then we let the open end face the universal set, and then the pointed end face the set A. Right, so that is how we denote universal sets and subsets. Alright, so let's move on. Okay, so still on subset. You see, usually you'll be asked to find a number of subsets of a given set. You see, like I told you earlier on that subsets are in levels, right? We can have different levels of subsets, right? So it means that if you have a particular set, you can have different kinds of subsets within a given set. Alright, so like the example that I illustrated, when you take Africa, we can have different kinds of subsets within Africa. So first we can have the individual countries serving as what? As subsets. We can have the individual countries serving as subsets of Africa. We can also have a relatively more involving subsets like the West Africa, Central Africa, okay, Eastern Africa, and Northern Africa. Right, so these are also subsets. Alright, good. And then when you come to West Africa, we can have subsets. We can have further subsets in West Africa. For instance, we can have English speaking West African countries. Right, English speaking West African countries. So you can talk of Ghana, you can talk of Gambia, you can talk of Nigeria, you can talk of Sierra Leone. Alright, so these are all what? English speaking West African countries. Alright, so it means we have different levels of subsets. So usually you can be asked to determine the number of subsets of a given set, or list the various subsets that are present in a given set. Right, so we are going to follow these simple steps, these simple rules, to help us list all the possible subsets of a given set. Right, so to help us, we have our set gene. So we are going to use our set gene to explain how we can determine the number of subsets of a given set. Right, so our set gene is equal to 1, 2, 3, and 4. Right, so assuming we are asked to list all the possible subsets of set G, how do we go about it? Right, so let's look at the first step. So each individual member of the set is a subset. So in listing the members of set G, the first thing we have to bear in mind is that each and every single member of set G constitute a subset on its own. So here 1 is a subset on its own, 2 is a subset on its own, 3 is a subset on its own, as well as 4. Right, so it means we have 1, 2, 3, 4. So here we have 4 different subsets, right? We have 4 different subsets, right? So this is one clue that will guide you. Each and every member of the set is a subset. Let's look at the second point. All the members of the set put together as one constitute another subset. Alright, so what this simply means is that every set is a subset of its own. Right, every set is a subset of its own. So it means that if you are to take Africa, Africa is a subset of Africa. You get me? So here, set G, all the members of set G put together as one constitute another subset. So 1, 2, 3, 4 all put together forms one subset. So far we've gotten 5, right? So we've gotten 1, 2, 3, 4 and then 5. Let's move on to the third point. Pair any 2 of the members, right? So we can also have another set of subsets, right? We can have another round of subsets, and that is where we combine 2 of the members, right? So we have 1 2, 1 3, 1 4, 2 3, 2 4 and then 3 4, right? So we have 1 2 3 4 5 6. So we have 6 different sets after combining 2 of the members, right? But please take note of this. Make sure you do not repeat any pair. Make sure you do not repeat any pair. So for instance, we are seeing 1 2 here. Do not rewrite 2 1, right? Because 1 2 and 2 1, they are the same. So make sure you do not repeat any pair. So 1 2, I shouldn't see 2 1 because 2 1 is also 1 2, right? So bear that one in mind. Okay, the fourth step is combine any 3 of the members. Combine any 3 of the members. Here to make sure you do not repeat any pair. Sorry, make sure you do not repeat any combination, right? Do not repeat any combination. So, and at this point you can have subsets like 1 2 3 as one subset, 1 2 4 as another subset, 1 3 4 as another subset, and then 2 3 4 as another subset. Right now, if the members of set J were more than 4, right? So assuming the number of members in set J were, let's say, 5 or 6, you would go on to combine 4 of the members. Here, because the number of members is only 4, we end at combining 3 of the members. But then if we had more than 4 members, we would have combined 4 of the members to create another round of subsets. Okay, so that's that. Okay, so let's go to the fifth point. A null set is a subset of every set, right? So a null set is a subset of every set. So as part of the subset of G, we are going to have this symbol, right? So 2 empty curly brackets, or this symbol, a 0 with a diagonal line drawn across it, right? So it means that for set G, one of the subsets of set G is what? Is a null set. Right. Now, if we are to count all the subsets we've gotten so far, let's see. Okay, so let's count them. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and then 16, right? So 16. Now mathematics has developed a formula that helps us to determine the number of subsets. So if you don't want to go through the ordeal of listing them one after the other, right, there's a simple formula that you can use to determine the number of subsets of a given set, and that is 2 raised to the power n. 2 to the power n, where n is the number of members in the set. N is the number of members of that particular set. Alright, so if we are to use this formula to determine the number of subsets of set G, we are going to write 2 to the power 4 because set G has 4 members, right? So 2 to the power 4, and 2 to the power 4 gives us 16. So you see it tallies with when we counted the individual members, we had 16, and when we also use the formula, we also had 16. Alright, so that is how to determine the number of subsets of a given set. 2 to the power n, where n is the number of members of the set. So assuming the number of members in the set is, let's say, 20, or let's say it is 10. I mean, if you have to list all the subsets, you would end up exhausting about 5 pages, right? So in order to help us determine the number straightforward, we just use this formula, right? So especially when you find it in your objectives, right? So you can just use this formula in order to save time, right? I believe you had it, right?